This is the lab lecture video for the procedure portion of the General Chemistry 2 lab titration of sodium hydroxide and KHP. There is already a video, or several videos for you to watch about specific skills, such as using the burette, measuring mass using weigh paper, and the setup of a titration. So I'm just going to hit the highlights of things that are specific to this lab, in addition to those other videos. So for this lab, the KHP is one of the chemicals we're reacting, and it is a solid. So we have to dissolve it to make it aqueous before we can do this reaction. So we need to use degassed, deionized water, which means we have to remove the carbon dioxide that's dissolved in the water. If you remember, like, well, it's not fizzy, there's no carbon dioxide, lady. As the water sits out, or just is exposed to the air, carbon dioxide dissolves in the water, which then becomes carbonic acid. Well, we're doing an acid-base reaction for this lab, and sodium hydroxide is our base. Sodium hydroxide as a base is going to react with any acid it comes in contact with. We want it to only react with the KHP. So that's why we have to remove the carbon dioxide, carbonic acid from our water before we use it. So right when you get in the lab, the first thing you're going to want to do is boil, or get ready to boil, 900 milliliters of deionized water. I would suggest getting 2 beakers, if possible 2 600 milliliter beakers, and putting 450 milliliters in one and 450 milliliters in the other of deionized water, putting them both on your hot plate, and then start heating them. So what needs to happen is those beakers of water need to get to a boil, like a rolling boil, like lots of bubbles, okay? Once it gets to that point, it needs to boil for 5 minutes straight. That's when you know that you're finished and you're ready to take those off and you've degassed your water. Now, to remove your beakers of boiling hot water, don't use your hands. Again, we're using the nitrile gloves for this lab. You will be using hot mitts. To pick them up, I would suggest 2. You will have 1 in your drawer. I can show you where the extras are for you to remove that, to set them on the counter. So it has to boil for 5 minutes. Now that's not going to be instant because water doesn't boil in, really, really quickly. So you're going to start that first and then start getting set up for the rest of the lab. Get your burette out. Condition your burette with the sodium hydroxide. Get your Erlenmeyer flasks, the 250 milliliter Erlenmeyer flasks out that you need to use. You can also measure out the mass of the KHP using weigh paper. So when we do that, when you measure out the mass of the KHP using weigh paper, you can watch the video about how to measure solids using weigh paper. You'll have solid on your weigh paper. You'll need to then transfer it very carefully to the 250 milliliter Erlenmeyer flask. So what I do is I make a taco and then put that in the top of the Erlenmeyer flask. What we want to do is we want to make sure all of that solid makes it down into the Erlenmeyer flask. Well, we can't rinse that until we have our degassed, deionized water. So you're just going to leave these here, because probably at this point your water is not heated yet, or at least it's not done boiling. So just leave them here. And then once your water has been boiled for 5 minutes and it's now degassed, you can add that to these Erlenmeyer flasks at any time at that point. It doesn't have to be all the way cooled. I would actually suggest not waiting until the water is all the way cooled. So you need to add, according to the lab, 100 to 125 milliliters of degassed water, but it has a little squiggly line, which means about. So if you're somewhere between the 100 and 150 milliliters of degassed water, you're golden. Degassed water's only job here is to dissolve the KHP solid and to be nice and clean and not contain any acid. So you can just pour the degassed water straight from the beaker into the Erlenmeyer flasks, falling somewhere between the 100 and the 150 milliliter line on the Erlenmeyer flask. But while you do that, rinse down the weigh paper. Once the weigh paper's been rinsed, it can go in the trash can. It's finished. You're then asked to add 1 to 2 drops of phenolphthalein, which is the indicator that's going to change colors for us. I would suggest just adding 1 drop. Phenolphthalein is also an acidic compound, so we have to have it in the beaker or in the container so that way it changes color. But we don't want to add too much, because if we add too much, it's going to react with the sodium hydroxide, and that's going to skew our results. You're going to need a stir bar. These stir bars must be checked out by your instructor. You will choose a number and check out your stir bar's number, and then at the end of lab, you will bring it back. Each group gets 1 stir bar. I know you're doing multiple titrations. Doesn't matter. You just get 1 stir bar. You'll add it. Okay. Now, I would suggest having a white background when you go to put your Erlenmeyer flask on your stir plate. So you can use a paper towel, you can use anything that's white, okay? And then you'll have your KHP, your degassed water, and your phenolphthalein. Oh, I lied. At this point, your degassed water is probably super hot. We have to get it cooled to room temperature before we can react it with the sodium hydroxide. So once your degassed water has been poured into your Erlenmeyer flasks, and you have 3 for part A, and so have the KHP already measured, and then pour the degassed water in it, you can take these and place them into your ice bucket that you'll be handed to help them cool faster. So as long as they get to room temperature, which for us, we're going to consider them room temperature is when you put them on your hand and they no longer feel hot. So it's going to have to sit in the ice for a while to get there. But once it's there, you're ready to begin your titration. So you can add your Erlenmeyer flask on top of your white background, on top of your stir plate, start stirring. Okay. And then you're going to record the initial value from the burette of sodium hydroxide. Add the sodium hydroxide. You're going to be stopping when you see the lightest pink color possible. So what's going to happen is the solution in the Erlenmeyer flask is originally a clear, colorless liquid. Looks like water. Okay. While you start adding the sodium hydroxide, you're going to see small amounts of like pinkish purple kind of show up, maybe like a pink purple tornado, and then it disappears. That's when you know you're getting close to the end point, which is where we need to stop. Okay, so once you get to that, where you're close to the end point, you will then start adding the sodium hydroxide very slowly because we don't want to overshoot it. We want to stop right when we need to. So when you add it very slowly, you're going to tip the burette, the stopcock valve here, either so that way it's just letting out drop, drop, drop at a time. But you want to make sure it's dropping so slowly that you can see that when it drops, you see the color, but then the color disappears. Because we want to stop when the color stops disappearing. For me, I screw that up horribly. So I do a quick 180-degree turn of the stopcock, like it's really quickly, and that adds a very small amount of liquid, like a drop, or about less than a drop. It looks like more than it really is. But then I have complete control over it, so I do like, you gotta make the noise or it doesn't count. And then I check to see, okay, did it turn purple? It did. Oh, the color disappeared. Okay, so I'm not done yet. So I'm gonna add another little bit. And then you gotta look. Did it turn purple? Oh, or pink or purple, however you want to call this color. Yeah, it turned pink. Oh, it went away. Okay, one more. And then it turned pink. Stirred, stirred, stirred. The color didn't go away. It's a really light pink color. That's when you're finished. Okay, so you've got to be on the lookout for the first appearance of any sort of pink color because that means stop just letting the liquid drain and you have to start adding it small increments at a time. Again, we want the lightest pink color possible. The color has to stay pink for 30 seconds for you to be at the end point. If it stays pink for 30 seconds and then the color disappears, as long as it was pink for 30 seconds, you're good. Then you will record the final value of your burette and be ready, done with trial 1, ready to go on to trial 2, where you'll use your magnet stick to remove the stir bar. Okay, rinse it off, dry it, put it in the Erlenmeyer flask for trial 2, and then repeat this whole thing. Fill up your burette whenever it gets below, I don't know, to be safe, maybe 25 milliliters. So whenever it gets down halfway, I'd fill it back up. You don't have to start at 0.00, the very, very top line. You just have to record where you start and record where you stop. And then part B, the only difference, sorry, I have an itchy, is going to be that instead of adding pure KHP, you're adding the unknown KHP, or the unknown. In part A, you're adding between 0.4 and 0.6 grams of the KHP to each trial. And in part B with the unknown, you're adding 0.6 to 0.8 grams for each trial. And the KHP and the unknown are both hygroscopic, which means they absorb water from the air. So the solids will be in a desiccator before you use them. Now, we are not going to weigh by difference. We're going to weigh with weigh paper. So what that means is keep the KHP and the unknown in the desiccator until you're ready to use them, and then keep their lids on very tightly, except for when you must have the lids open to scoop the solid onto the weigh paper to keep them dry, because we need the mass of the KHP to be nice and clean and not yet contaminated with water. Once it goes into your weigh paper and you've written down your number, it's okay for it to sit out because you already wrote down its mass. So now if it absorbs water from the air, I don't care because I know how many grams of there was before it absorbed water from the air. Okay, so you're going to do this titration 3 times in part A, and then with your unknown, you'll repeat the same setup 3 times in part B, so 6 total titrations. At the end of the lab, you will have to return your stir bar. You'll have to drain your sodium hydroxide from your burette and then place the burette in the designated container. And all other glassware you will wash and put away. Now, chemically, none of these chemicals can go directly down the drain right away, but there is no waste container. So they all must be neutralized to a pH of 6, 7, 8, or 9, and then they can be dumped down the drain. So I would suggest for you to have 2 waste containers at this point. Have one big beaker, maybe a 600 milliliter beaker, maybe a 1 liter beaker, whatever, where you're going to pour in all of the pink solutions, all the solutions from the Erlenmeyer flasks. And then your other beaker, which can be much smaller, I'm guessing like a 250 milliliter beaker, pour all of the pure sodium hydroxide. So the leftover from the burette, whatever sodium hydroxide was left from conditioning, and plus any sodium hydroxide that's left that you poured out of the stock solution that you didn't use. So you're going to have 2 waste beakers, the pink reacted solutions and the pure sodium hydroxide. Hopefully your pink reacted solutions, all we need to do is test them. Their pH should be in the 6, 7, 8, or 9 range naturally, which means then you can just dump them down the drain. The sodium hydroxide will absolutely not be a pH of 6, 7, 8, or 9. It'll be a pH of 12 to 14. So we will have to neutralize that. Once it is neutralized down to a pH of 6, 7, 8, or 9, it can then be dumped down the drain and your glassware can be washed. So you have to check out your stir bar at the beginning and check it back in at the end. You will use the magnet sticks to remove the stir bar from the Erlenmeyer flask, but these magnet sticks, we don't have one for each group, so we'll have to share. And make sure not to dump any chemicals directly down the drain without checking their pH value first. The ice buckets are only to be used for the Erlenmeyer flasks, so you'll pour the water into the Erlenmeyer flasks before you put it in the ice bucket. Do not put the beaker directly in the ice bucket. That beaker is going to be super duper hot because it just sat on the hot plate for a long time. It's going to melt all the ice and your water will not be hardly any cooler at all. So it's much better to transfer the hot water to a cool container, not a cold because that would break it, but hot water into a room temperature container and then put that into the ice. So that way the ice is just cooling the hot water. It's not cooling the glassware. Okay. So yay for titrations.